What is the best telescope of the world? Easy question, right? Yet it gives the usual, most feared answer of astronomy. It depends. Welcome back to Boring Astronomy. I'm Alessandro, your astronomer next door.
Boring Astronomy.
In case you are wondering, I'm Alessandro. I have been in astronomy for the past 20 years, and I'm here to share with you some of the things that I learned along the way. During the course of the many years I have been in astronomy, I have been using telescopes from as small as 30 centimeters to as big as 10.4 meters. And I have heard the best telescope of the world so often that I think it is time to summarize and give you an interesting perspective on this. Let me give you an easy example. What is the best car out there? If you would ask me, my favorite car by far is this one. It's the Ferrari F355. It's a beautiful car from Ferrari from a few years ago. Does it even make sense to drive a Ferrari F355 in a city where the speed limit is 50 kilometers an hour? Or off-road where everything is bumpy and you have big rocks? No, it doesn't make sense. With telescopes it's exactly the same. The kind of telescope you're going to use will depend on how you want to use it. So yes, the best telescope, it depends on what you need it for. Assume that you want to observe an object which is visible with naked eye. A very big telescope like optical telescope of 8 meters is absolutely useless because you will get too much light inside the telescope. If you care for X-ray astronomy, again, a very big telescope working in the optical on the ground is going to be of no use to you. So there's a lot of different types of telescopes, and this is what we're going to speak about today. If you follow this channel, you probably already know that the first person to use a telescope for astronomy was Galileo Galilei in 1609. And here you have a replica of Galileo's telescope. Since 1609, the technology of telescopes has evolved a lot in the way of making lenses, the way of making mirrors, and the need for telescopes has only expanded. The first telescopes were refracting telescopes. From an optical point of view, I will not bore you too much with all the details here. You have two lenses, and what they do working together is they allow you to see an object which is far, far away. It was thanks to Sir Isaac Newton that we started moving from the idea of having two lenses to use mirrors. And this is a replica of one of Newton's telescope, and in this case the idea is that the light bounces off of a mirror, then another mirror, and then it reaches your eye. Nowadays, instead of the eye, we put instruments, normally CCD cameras, very much like the one you have on your mobile. As time evolved, we started to build telescopes which were bigger and bigger. The largest refracting telescope there is and can still be used today is the one at Yerkes Observatory, and is 40 inches, which is 102 centimeters, and is this beauty here. The problem with these telescopes is that the lens has to be very, very big, 40 centimeters in this case, and lenses are difficult to make. Mirrors are much easier, and that is why with mirrors we can build mirrors which are as big as 8 meters. So the example here is Subaru VLT, Gemini, which are all in the range of 8 meters. Comparatively recently, early in the 1990s, we started to make mirrors which were segmented. In other words, instead of making one very big mirror, we would make relatively smaller mirrors which altogether they can act as one. each of these segments, as we call them, they can be as big as almost 2 meters. And this is something relatively easy to do. So you can see that the largest lens we can build is 40 centimeters, and a mirror which is not too difficult to make is 2 meters. The important message here is the largest this number, the more photons, the more light you collect. And this view graphic, which has been around for a few years by now, is very, very useful. It shows you some of the telescopes which are operating nowadays, very large telescope in Cerro Paranal, the 2 Magellan telescopes, the Hubble Space Telescope, the James Webb Telescope, and the telescopes which are being built nowadays, which are the Giant Magellan Telescope and the Extremely Large Telescope. I may make a specialized video about these two. The thing is, most of the telescopes I've been mentioning so far only operate in the optical and on the ground. Possibly one of the most iconic telescopes out there is the Hubble Space Telescope. And when I did a course on optical engineering, the very first telescope we designed, because its optics is so handbook example, is the Hubble Space Telescope. The Hubble Space Telescope has been in space for more than 35 years. From an optical point of view, the Hubble Space Telescope is a relatively easy telescope. In fact, it's a Richer-Chrétien telescope, but basically the scheme is very similar to the Cassegrain. I will spare the details here. The light arrives from the stars, bounces off the primary mirror, arrives to the secondary mirror, and the primary mirror has strategically a hole so that the light passes through and gets to the instruments. The JWST, which is now 6.5 meter telescope in space, works very much on the same logic, only it has a segmented primary mirror because it was easier to launch into space. In case you're curious, the largest mirror ever sent to space is the one of the Herschel telescope, which was a European mission, and the telescope was 3.5 meters. If you really want to see something interesting, those are the radio telescopes. Radio telescopes look like nothing but the idea of the telescope that you have in mind. This is a radio telescope, so this is a giant antenna at Parkes Observatory, and this is also a replica of actually the very first radio observatory made by Janskis in, if I'm not mistaken, the 1930s. Radio telescopes can be huge. This is an example, the 100-meter telescope at Effelsberg. This means that the diameter of this dish, I'm not calling it dish out of disrespect, we normally refer to this as dish. The diameter of the dish is 100 meters, so you can basically imagine a football field being moved around. And then there are some telescopes which are so big that they literally cannot be moved around. The concept of best telescope, as I said, depends on the kind of science you want to do with it. So it's not only the telescope, but it's also the instrument that you have attached to it. You can have telescopes which are perfectly identical, but one telescope is completely specialized at one thing and is much better at that science case than another one. A very good example are the 3.6 meter telescopes. One is in Chile at La Silla Observatory, and the other one is at the Calar Alto Observatory in Spain. The 3.6 in La Silla has installed HARPs and nowadays also NIRPs. The two instruments are absolutely super specialized in detection of extrasolar planets, and that is the only thing that that telescope does nowadays. And that telescope is a planet finding machine. The 3.6 at Calar Alto has a little bit more complicated use model, so it's not as specialized as the other one. Does it mean that the 3.6 in Calar Alto is worse than the 3.6 in La Silla? No, its science case is different. And this is the message of this video. There's one question that I love to ask students, and is, what is the largest telescope of the world? If best is qualitative and very much subjective. The largest telescope of the world is something standard and is something measurable, hence objective. So what is the largest telescope of the world? I'll give you 1 second to think about it. It turns out that the largest single mirror that one can build is about 8 meters. Now the single largest telescope that there is the Very Large Telescope, which is at the same level at Subaru, and they have 8.2 meter primary mirrors. The thing is, the largest optical telescope of the world, in fact, is the Gran Telescopio Canarias in the island of La Palma, and I'm putting here a picture that I took when we were commissioning the first instrument on it, and the primary mirror is made of 36 segments, each of 1.8 meter of diameter, basically as tall as I am. Is this the largest telescope of the world? Well, for optical and near infrared, yes it is. The moment we start to speak about radio telescopes, the thing changes significantly. This we have already met is the 100 meter telescope at Effelsberg in Germany, and this is the 100 meter telescope at Green Bank in West Virginia, United States. Are these the largest telescopes of the world? Many of you will have heard about the telescope of Arecibo, which was a telescope in Puerto Rico, which unfortunately collapsed a few years ago. The telescope was so big, 300 meters across, that the telescope was literally inside a valley, and it only could point towards zenith, and it was the instrument on top which was allowing it to point here or there a little bit. What nowadays is the largest single dish radio telescope of the world is the 500 meter aperture spherical telescope, FAST, which has been built in China and started operation, if I'm not mistaken, 2016. So this means that this dish is 500 meters across. Is this the largest radio telescope of the world? You guessed it. No, it isn't. Atacama Large Millimeter Array has 66 radio antennas, and again they can cover a vast area in the Altiplano de Chajnantor in the north of Chile. Is this the largest radio telescope there is? You likely remember this image, which is the image reconstructed of the light bent around the black hole at the center of the M87 galaxy. This was done combining a series of radio telescopes around the world in a project called Event Horizon Telescope. And these are the telescopes which, combined together, make the Event Horizon Telescope. So yes, as we speak now, this is the largest telescope of the world. Now, there is a bonus track here. Do you know that there is a telescope that you use every day? This is the optical scheme of the telescope of Galileo Galilei that we've seen before. On the left you have the first lens, then the second lens, and your eye is the detector where the image formed. This is the human eye. At the entrance you literally have a lens, and at the back of the eye you have the retina, which is where the image is reconstructed, and then you have the optical nerve, which is where the image is transmitted to the brain for processing. So literally the human eye works exactly as a modern telescope. I hope that after this video, as boring as it might have got, you will remember that there is no such thing as the best telescope of the world, and that this statement is actually quite pointless. Telescope is a tool which is as good as the science you want to do with it. What I want you to remember is all photons are created equal, and all telescopes, they deserve to be cared and loved for, because they are the tools to do the science that we love. So next time someone asks you what the best telescope out there is, ask them back, what is it that you want to use the telescope for? Write in the comment what is your favorite source, and what is your favorite telescope, and what is your favorite combination of them, and I'll see you next time. Ciao!